The evolution of excellence, a journey through software quality. Hello everyone, my name is Stella Sewejakwa, a level 300 software engineering student. Today, I'll be taking you through the history of evolution of software quality. Software quality refers to how well software meets user requirements, performs correctly, and operates without defects. Over the years, software quality has evolved from simple debugging practices to advanced automated and AI-driven quality engineering. Let's explore this journey together. In the beginning, early computing and the dawn of bugs. In the early days of computing, software was very simple compared to what we use today. Programmers worked directly with hardware and had very few tools to help them. One famous event happened in 1947 when computer scientist Grace Hopper discovered a moth trapped inside a computer relay. This incident led to popular term debugging, which means finding and fixing errors in software. At that time, there were no formal testing methods. If a program failed, developers simply fixed the problem and tried again. Software quality was mainly judged by one question: does the program run without crashing? Software quality was informal and focused only on fixing errors after they occurred. Let's move to the software crisis and the rise of structured programming. As computers became more powerful, software projects became larger and more complex. Many projects exceeded their budgets, missed deadlines, and produced unreliable software. This period became known as software crisis. A major problem was spaghetti code, where programs became so tangled and disorganized that they were difficult to understand or maintain. To solve this issue, developers introduced structured programming techniques, which encourage writing organized and manageable code. The software crisis showed that software needed proper planning and quality management. Let's look at quality assurance emergence, testing, methodologies, and standards. During the 1980s, organizations realized that software quality could not depend solely on fixing problems after development. Formal testing methods were introduced. This includes unit testing, which tests individual components, integration testing, which check how components work together, system testing, which evaluate the complete system. The V model was also introduced to connect development activities with testing activities. Organizations started using standards such as the Capabilities Maturity Model, known as CMM, and ISO 901 to improve quality processes. Quality assurance became a structured and planned activities rather than an afterthought. Let's move to the internet boom and the need for speed. In the year 1990s, the internet boom and need for speed. The rise of internet changed software development dramatically. Companies could no longer spend years building software because users expected faster delivery. To meet these demands, new development approaches emerged. Rapid application development, or RAND, focused on creating prototypes quickly. Extreme programming introduced practices like pair programming and test-driven development. These ideas eventually influenced the Agile movement, which emphasized teamwork, customer collection, and delivery working software quickly. Organizations needed faster development while still maintaining software quality. We are moving to automation takes hold. That's automated testing and continuous integration. When we talk about that, as software system became larger, manual testing alone was no longer sufficient. Automation became the foundation of modern software quality. Several important tools appeared during this period. JUnit helped automate unit testing. Cruise control supported continuous integration. Selenium automated web browser testing. Huston and Jenkins automated build and deployment processes. The major changes was that the quality was no longer checked only at the end of development. Instead, testing became continuous throughout the development life cycle. Automation made software testing faster, more reliable, and more efficient. Let's move to the cloud, mobile and DevOps quality at scales and speed. In the year 2010, cloud computing, mobile application, and DevOps practices were introduced. Cloud platforms required developers to test distributed systems and microservices. Mobile applications created another challenge because software had to work on thousands of different devices and operating systems. DevOps brought development and operations teams together, encouraging collaborations and continual delivery. As a result, quality became everyone's responsibility, not just responsibilities of testers. Software quality expanded beyond testing and became integrated in every stage of development. We are moving to the present day. AI, machine learning, and the future of software quality. Today, artificial intelligence is transforming software quality. AI too can automatically generate test cases, predict defects, and analyze software behavior. However, AI is not replacing quality engineers. Instead, it helps them work more efficiently by handling repeated tasks. A modern approach is called shifts everywhere, where quality is considered from the design phase all the way to production monitoring. Quality assurance is evolving into quality engineering, which focuses on building quality into software from the beginning. AI enhances human capabilities and helps create higher software quality. Key milestones and lessons learned here. There are four major lessons from history of software quality. First, we learn quality is mindset, not just a phase at the end of development. Second, processes should support people rather than limit creativity. Third, automation helps team work more effectively but does not replace human judgment. Finally, different projects require different quality approaches because context matters. Successful software quality depends on people, processes, tools, and adaptability. What's next? That's embracing a culture of continuous quality improvement. The future of software quality depends on continuous improvement. Organizations must encourage every engineer to take ownership of quality. Teams should use data and feedback to improve their processes. Most importantly, software professionals must stay curious and embrace new technologies and methods. Quality is not a destination, it's an ongoing journey. Continuous improvement is essential for long-term software success. Let's look at the case study. That's a historical failure. What went wrong? IBM's operating system 360 project became extremely expensive because of poor project management and growing complexity. This demonstrates the importance of planning and quality control. Terac 25 radiation machine contained software defects that causes fatal overdose. This tragedy highlighted how software quality can directly impact human lives. Modern success story. Google runs millions of automated tests daily, helping to maintain software quality at a massive scale. Netflix uses advanced DevOps and continual delivery practice to achieve extremely low deployment failure rate. Microsoft also uses AI-powered tools to detect software defects automatically, improving efficiency and reliability. Real-world example show that poor quality can cause disaster, while good quality practices lead to success. To conclude, software quality has evolved from simple debugging practices in the 1940s to today's AI-assisted quality engineering. Each era has contributed valuable lessons that help us build more reliable, secure, and efficient software systems. Thank you for listening.